Joining for this event. Looks like yesterday has been a great day, and we all hope that you have a wonderful day today. And there's a lot of good speakers and topics lined up, and look forward to all of you having a great experience. I'm Amit Chatterjee. I lead the Visual Studio test business for Microsoft. I work out of Hyderabad, but I have a distributed team with team members in Hyderabad, in Redmond, Washington, as well as in Raleigh, North Carolina. And it is a privilege to lead this business for Microsoft, and that to be able to do that from India. In the 20 years, or close to 20 years that I have been in Microsoft, it's been fascinating to see how technology has evolved from the days of desktop applications, which were kind of isolated and only working on the desktop, to today's world of very distributed and rich internet applications, to service-oriented architectures and software and service. It's been a phenomenal evolution. But it's been interesting that just as it was several years back, building software for enterprises for the scale that we need today continues to be really hard. For many of us who are developers, we have constantly been looking at newer tools, working in our offices and cubicles, looking for newer tools to build the architectures and designs for these internet and enterprise applications. But today's software engineering isn't really about just as a developer writing code and doing your design. Software engineering itself needs to be a lot more encompassing. It needs to be a platform where seamlessly and naturally all stakeholders that are involved in building these enterprise applications come together. This could be from the business side to the IT, could be from people who gather requirements for applications to people who eventually host the applications in the data centers. So it is really all about sort of breaking down the walls or silos that we have in today's development world and really building a set of bridges which encompasses and includes all of these disciplines. So over the course of the next 20 minutes or so, I'll talk to you about essentially the philosophy behind this. Why do we need this? And also introduce the Visual Studio team system from Microsoft. At Microsoft, we have been in the developer division for forever that we have been in our business for the past 30 plus years. But we are fascinated by the opportunity now where we can literally perhaps change software engineering itself to keep pace with how the technology is evolving. How many of you, by the way, are aware of Visual Studio Team System 2008? Could I see a raise of hand? Okay, well, maybe 20-25%. How many of you who know of VSTS are aware that we have a testing platform in there? Okay, that's good. That's almost all of you. So that's good. So with that context, let me first lay down the context of, let's see if this works. Yeah. Let me lay down a context of how far we have come with software engineering. For the past decade or so, one of the main focuses in the industry has been really about driving cost down. And to a large extent, we have been quite successful at it. The graph over here shows that over the last 10, in the 90s, last 10 years or so, we've been able to bring down cost overrun by more than 100%. But the question is, should the industry continue this focus on reducing cost, and will that lead to better software? Before we answer that question, there's another interesting statistics that I'd like you to take a look at. This one shows that over the last 10 years, if you take a look at projects which have been considered to be successful, the number is roughly still only about 30% across the years, and there have not been any significant change in that statistic. This is a terrible statistics, in my opinion. In the 21st century, when we talk about how technology has evolved, software engineering is still at a state where only 30% of projects are considered to be successful. And really, I don't know of any other business where 30% success is tolerated or even cheered. And we seem to do that in our business. And that is an appalling statistic. So this essentially says that driving costs down isn't the only solution. What literally has happened is we are making it less expensive to now fail, but we are still failing just as we were 10 years down the road. And we need to understand why that is happening, and we need to address that. And this is where I believe here's an opportunity of really changing how software engineering works. And coming from a developer background and the audience being in this developer segment, I think that's a great opportunity for us to collectively work together and change software engineering. So if you analyze why the projects are failing, there are primarily three reasons, in my opinion. The first one is lack of a business alignment. So while in today's IT, in today's world, IT is really being adopted ubiquitously across businesses to evolve business needs, there is still a lack of involvement between business and IT. The user involvement and the stakeholder involvement in the applications that are being developed is low, and that needs to be changed. The way we manage, figure out requirements and manage the scope of those requirements isn't too good, and that's leading to failures, and we need to change that. As well as I said, business and IT really need to come together for us to affect those 30% success rate that we are seeing right now. The second one is about software quality. We really need to work towards moving software quality upstream. Being part of the test business, this is something which is very close to my heart. If you think about it, today, the way we define software quality, by finding defects in the product and trying to fix that, it's too late in the game. We are trying to find the defects after they have already gotten into the product, and that's too costly. We need to find a way where software quality is moved up front. We need to drive towards a way where perhaps someday we'd have provable and testable software. Perhaps someday it will not be possible to enter bugs, or the system and the tools will find the bugs right at the source and not wait for this effort at the end of the cycle to find it. So software quality is very important. And if you look at the graph, as I said, we are reducing costs, but what's happening, we are passing that cost on to the end users. Because as we ship software which is not up to the mark, which has defects, it is our end users, it's our customers, it's the business as a whole that's suffering. And that can't be good. So we need to address that. And the last big challenge, in my opinion, is productivity. As applications are becoming increasingly complex, as we are getting into this industry where, on one hand, the applications themselves are distributed, on the other hand, the teams which are building these applications are distributed, productivity and efficiency becomes paramount. So if you take a look at this graph over here, which says that as the size of the project team increases, the actual productivity seems to decrease because of the overheads of project management, and communication issues between disparate groups, and increased complexity. So lack of business alignment, software quality, and productivity challenges are the things which are plaguing software industry today. And if you try to analyze why this is happening, the answer is quite clear. Take a look back at the 1990s think about how software was being developed then. It was a bunch of developers working in their cubicles and offices and writing code and compiling, designing, and doing software as such. And the only collaboration within the enterprise was really just across these devs with some basic set of tools, maybe source code control tools or a shared IDE. That's what software engineering was at that time. Just a collaboration, minimal collaboration between devs, but devs still sort of working in silos. Now, as I like to say, these projects which are failing today aren't failing because developers aren't able to write their code or compile their code or come up with design. It is failing perhaps because software development today is not just about the core development practice. In the 2000s, and this was a realization, in the 2000s, we moved towards realizing that to pull together a complex software application, you need to focus on multiple constituencies. There are the project managers, there are developers, there are database professionals, there are professionals in test, there are people who design the architecture and operations, and all of these need to sort of come together for a software to be successful. And for many of the big players in the industry, including Microsoft, our focus was to build this trustworthy transparency amongst these set of constituencies. For example, when you're building a new application, right, and you're at the architecture stage, there's no reason you cannot think of your testing strategy right there. Code may not have been written, but you should be able to figure out that if that's the architecture, this is how my testing strategy ought to be. And the tool, the platform, ought to support that. So that's been sort of the focus where in the 2000s, if we have been trying to build bridges, it has now been across these different constituencies that come together for building a commercial application. Now, together with that, there's also a paradigm change that we need to be aware of. Traditionally, project management in software world has been what we call a sort of a work-down approach, where you come up with an overall plan for the entire product, you then decompose that into individual tasks, and once you have done that, your entire focus in project management and tracking that project goes towards completing these set of tasks, figuring out how you can do those with your resources and cost that is allocated to you. Now, this approach works pretty well for traditional engineering, like building roads and bridges, etc., where relatively speaking, the design risks are low because we have figured that out. And relatively speaking, the cost of building is much more than the cost of design. Hence, you come up with the design once, and then you focus on working through the tasks. And also in these industries, it is difficult to provide incremental value along the way. For example, of course, if you're building a bridge, you can't drive a car across it if it's half built. You need to wait for that to complete. In software, we have sort of been sticking to the same model, and that's not been working too well. We believe that in software, the right approach now, keeping the trends, is more of a value-up way of looking at software building, where you think of your product, you think of your value props that you want to provide for the end users, and then you iteratively build upon those, right? All along the way, the focus is on measuring value to the end customer. It is not about your own cost. It is not about how the tasks are broken down, because at the end, this software has to be for the customers. In Orcus, in Visual Studio 2008, for example, the code name was Orcus, we followed the same approach, where the entire Visual Studio 2008, that was a pretty complex product built over 2.5 years of time. We broke it down into about 30 value props. That was our focus, 30 value props for the customers. We broke those 30 value props down to experiences. For each value prop, what are the experiences our customers are going to be getting? And then from the experiences, we built a set of features. So the data was something around 30 value props, about 150 experiences, then about 650 features. And we drove this process iteratively. At each iteration, 5-week, 6-week iteration, you do a review, figure out that you have developed that feature, potentially could share it with the customer and get feedback and then build upon that. So that is what we call the value up way of working, as opposed to a work breakdown way of looking at things. And that's sort of like a paradigm change within the industry. And this way of doing development forces you to ask a set of different questions. In traditional software engineering, you're looking at number of bugs or number of features that's done or not. In a value-up way, your focus constantly has to be on the requirements, the end-user value prop. So you need reports which tell you, how much of your requirements are tested, how much is not, where there's some issues, and you want to be able to drill down into that. In today's world of distributed development, you want to have a better sense of how is your execution capacity shaping up. Traditionally, people, they try to measure their execution in terms of, the active bugs and test passes, etc. But you can do much better. The system itself can instrument your activity, which can provide you a much more richer level of detail, where, for example, not only just your pass rate and your bug count, you need to be able to take a look at your code churn. How often is the code changing in that area, which might invalidate your test passes? How much is your code coverage? And so a different set of metrics. And the platform, the system ought to be able to build this up. You don't need to do this manually, right? So that's sort of the focus for Microsoft as we enter this application lifecycle segment. And our goal is essentially to look at constantly figuring out where are the walled silos in product development and how can we turn them into bridges. So our focus is really on the set of people at an individual level, where we want to reduce complexity. We want to bring about a mindset of quality and a culture of innovation. At a team level, paramount is collaboration, transparency, and integration. And at the enterprise level, we want to be focused on agility in terms of effectiveness and alignment. So we want to be able to keep these in mind and build essentially a platform where the tools, the people, and a platform and guidance all come together exploiting all the natural relationships that you have amongst these different set of entities in your system and build the best possible experience for building software development. So that sort of has been our focus for the application lifecycle segment. And we, in a couple of months back, few months back, we have released Visual Studio 2008. It's a great product. For those of you who have used it, hopefully you'll agree. And for others, it'd be a great opportunity for you to take a look at that product. And later in the day, my colleague Nilesh will have more of a detailed view of the VSTS product. I'll share with you just a little overview of what this product is about. The product, VSTS, is essentially a set of components which come together. At a fundamental level, we have a server product called the Team Foundation Server. And the philosophy here is all of the artifacts, all of the metadata, all of the actual data that you can use during a product development across all disciplines are in this server, with the goal that any inherent relationship that you have amongst them can be built up, can be mined, can be trended, and can be brought forth. So essentially, this server is used for project management. It tracks your work items. It's your version control system. Your source code stays here. The reporting is done from here. The builds are done from here. If you have test team, the test plans, the test data, all of it is now finally in one place. And we have a rich reporting and relationship exploiting capability, which builds up all the relationships that we need for the projects to be successful. When you start a project, you have an opportunity of defining a project, at which point you get the automatic guidance. You can set up your configurations, whether you want to do an agile way of developing, and that takes you through a state which is appropriate for agile development. Or if you want a more formal, CMMI way of developing projects, you can have an appropriate set of templates to define that. On top of the base server, you have a set of client products which focus on the individual segments of development, architecture, development, database, testing. And the goal there is, once again, to bring tools specific to that discipline, but at the same time, make sure that the commonality, the inherent relationship across these disciplines is brought forth. For people who are part of the project team who are not engineers, we have excellent Office integration where project managers and business analysts can be able to get that data through Office or Excel and project and get their information that they need out of that. For people who don't want a client product and want to work through the web, we have all of the capabilities, nearly all of the capabilities of the Team Explorer exposed through the web. Beyond that, this is sort of like a platform from Microsoft's perspective. Our goal is, as long as new development technologies keeps evolving, as the world evolves, we build in extensibility points where, whether it be Microsoft or our partners, we can potentially keep adding newer capabilities to that. So we have opportunities for third-party tools, and there's already a rich set of partners who have taken to this platform, and they're building solutions on top of it, as well as other extensibility points. Several, for example, we have a partner, Team Price, who is building an Eclipse front end for running Java projects based on TFS. And that's a phenomenal opportunity where we believe that the VSTS is a platform, and for whatever need that you have in your enterprises, you're able to build upon that based on this platform. So that, in short, is a little bit about the product. And once again, the whole goal here is to move this value-up paradigm to the people and let them realize that, what does it feel to break out of your silos, to collaborate, and to essentially then try to target that, the dismal project success rate of 30% that we talked about. And I was thinking of, what's an analogy in terms of this paradigm changing stuff that we're talking about in history. And, the closest analogy that came to mind is, breaking down of the Berlin Wall. For 30 years, there was this wall separating separating East and West Berlin. And when that thing finally broke down in '89, it was an exhilarating feeling. And that led to so much of socioeconomic progress in that area and all of Europe. And that's really what happens in real life when you break down the walls and then let all the good stuff sort of happen. So that's sort of the thought that we have in mind. And this is not the end, by the way. Going forward, for example, in the next 10 years, we need to carry this building of bridges even further, where the focus really has to be doing on the right thing. What is the right thing? At the end, how do you know that you're done? And along the way, if you keep quality in mind, how do you ensure that quality is constantly moving upstream and you're building the product in the right way? And here's a great opportunity. I talked about the PMs, the developers, the testers, sort of breaking through their silos and coming together. And as that unit within the organization, they now have a phenomenal opportunity to connect the dots with the rest of the organization. Whether it be your business analysts who are defining the requirements, your designers who are designing the front end of your applications, or your operations people who are eventually hosting your applications. Right? So really take this concept of building the bridges across the entire operations, right? And that's the day when I think software engineering will perhaps come to the stage when we would see much more than 30% success rate that we are tolerating, all of you are tolerating, and we are celebrating, but in our hearts we are still quite ashamed of where we are. So that's where we want to take the software products to and the technology to. And what that means in many ways is much more clarity, much more transparency into what's going on across this segment. For example, the PMO's office, the guys who are funding your projects, ought to be able to have a clear visibility of how the project is going on. I show a report here where you see a piece in red, and this also happens to be the project which has the most funding, all right? And apparently things are not going well. You need to have that sense up front, and you have this view which is quarter by quarter before it's too late. You get a sense of what's going on, and you're able to drill into that and see what's happening. So I'm just giving you a set of experiences. As a tester who's focused on quality, as I said, the key thing now is, in terms of quality metrics, it has to be related to your business goal. Quality is not just about figuring out test automation is 100% or not, or what your bug rate, etc. is. It needs to be about how's your requirement test coverage, how's your requirements pass rate, and you need to have that information right up in your dashboard, so to say, so for you to be able to make the right decisions, right? From a bug perspective, right? All of us developers, and you would relate to this. How many times we run into a situation where a tester files a bug after a lot of effort, it comes to a developer, and developer tries it on their machine, and it's not repro, right? Such a waste of effort. How can we remove this not repro phenomenon which has been plaguing us for years? What if when a tester is filing a bug, automatically, right, when you click the button and says file the bug, a lot more information about your system is automatically put into your system. For example, what if there's a video recording of what the tester was doing which led to the bug, which was automatically captured? So when the developer gets it, the developer just plays that video and embedded in that bug report, and now you see how the tester got into the situation leading to the bug. Or at least now you'll no longer be able to say it was not repro because there's evidence, irrespective of how the tester might have captured the tests. What if you have a set of logs, right? We are familiar with stack traces and event logs and all of that. What if that information was in a time-stamped way, whereas, so when the developers get the bug, they are sort of able to do TiVo-style debugging, right? They can go backwards and forwards in time. If a field is clobbered, they can go back in time and see what was the value of the field at a certain time in the past and forward and fix the bugs. This is the sort of sort of the collaboration that I'm talking about that's possible in this space, which is across the constituencies, which will keep moving quality upstream and make sure that everybody in the organization, right from the PMOs to the devs, test, to the operations guy, they have great clarity and transparency in terms of what's going on in the system and what needs to be acted upon. So that's sort of in brief what I wanted to cover with you today. And to go back to that analogy of building bridges in the Berlin Wall, I talked about the experience that was there when the wall was broken down. And I believe this is how it is today. And I think just as in real world, when the walls are broken down and bridges are built, and it's a phenomenal success, it leads to many different opportunities that were otherwise not thought to be possible. Also in software engineering, we can do a similar experience. We can provide a similar experience for ourselves, for our customers, and collectively hence work towards the case where that statistic, which still rankles in my mind of only 30% success rate, we are able to defeat and transcend that. Thank you. So that was my talk today. There are about 5 minutes left. I'll be happy to take a few questions if you have any. Any questions? All right. So, yes, that's the Standish Group report. More than 70% success or failure? Right, so it depends upon, so essentially see, the way you take a look at success is subjective, right? You could say a failure is a downright failure where you can't even build the application. A failure could be, it could still be a failure when you have shipped a product and you celebrate, but it's still a failure if down level, right, as you're deploying the application, there are bugs and constantly the people are patching, right? And there's a statistic which says annually in the US alone, $60 billion is spent every year in maintaining. So if you're spending so much time and effort in maintaining your applications, where do you leave yourself bandwidth for innovation, right? So you can say that you have shipped a product, but that can be construed as failure. Or perhaps you have shipped, but it took so long for you to ship that application that the industry has changed. That can be construed as a failure, right? Yeah, sure. So that is something that we are, so the question was, does Team System has a capability of managing requirements? We have some partner products which do that today, and we are building on that capability in this next version that we are currently working on. Absolutely, so testing is the main focus area. That's the area that I'm leading, and in fact, Microsoft in the last year or so, we have increased our investment in the testing space from a team of about 20 people to now 120 people. So testing is a major focus for us. And Nilesh in his talk will be covering a lot more of that. We are excited about the opportunities in this space. Yes? Sorry, project estimation attributes? Right, so how much does project estimation go to failure of project? Is that what you're saying? Yes, that's the big ask. You know, you're asking about requirements. There are a lot of ways when you capture requirements. Today, in many ways, that's a static thing, right? You start with a set of requirements, and you seem to have gotten it. Now you start your development. But in real life, your requirements change, and you can't now quite figure out what needs to change in the system. So in many ways, requirements, estimation of the projects, all of those play a role. That's why this value-up paradigm, where you're incrementally building up on your thing, and you're building a good traceability between your requirements and your estimation and your actual tasks, which is very important for success. Sorry? Is there a project management? Right, so that's the one which we are sort of working on right now. Sorry? How? Yeah, so traditionally all of the tools, technologies that you would need from a traditional project management perspective in around requirement storyboarding, eventually we'll get to that. All right, thank you very much.